To all our participants, good afternoon, or for some, good morning, or for some, good evening. In any event, we are delighted that you're here. My name is Randolph Kent. I'm a former UN official, and I'm director of the Humanitarian Futures Platform and also a visiting professor at King's College London. Today's webinar, Advancing Humanitarian Responses Through Space Technology, comes, as I've said, at a challenging time across the globe. All of us know in various ways that the types, dimensions, and dynamics of crisis drivers are increasing, in some instances exponentially. And we, the international community, have to prepare for these challenges. The United Nations, for one, has made it very clear that outer space technology could soon become a major factor in ensuring the Sustainable Development Goals and also in addressing so many of the complexities we face in anticipating and dealing with future humanitarian crises. Now, what I would like to do is to begin to say how delighted I am that we have such a distinguished panel. And I'd like to just mention their names. I shall introduce them more fully when the individuals speak. But let me just say right now how delighted I am to see Dr. Shirish Ravan from the UN's Office for Outer Space Affairs, Liz Cox from the UK Space Agency's International Partnership Program, Professor Thais Russomano from King's College London, and Dr. Ian Pearson, a full-time consultant on futurology. Now, let me tell you a bit before introducing each of them about the process. This is a 70-minute event that what we would like to do is to give each of our distinguished speakers 3 minutes to give a sense of where they feel this subject matter is going, and then to open up the questions that the various speakers will be answering. Let me just emphasize here that so many of the questions which our distinguished panelists will be answering will be yours, will have come from you. So I am delighted that so many of these questions are your questions. Now, that said, towards the end of our session, what we're going to do is to ask each of the panelists to reflect on what they said in the first 3 minutes, to put this in the context of the questions that you have posed and which the panelists will have answered. And each will have 3 minutes to summarize where they think we've been over this 70-minute journey. Now, let me just say, I think one of the things that I am so grateful for personally, and I think probably all of you in one way or another would be, is that after this particular webinar, that the World Humanitarian Forum will put all of this together in a kind of coherent, consolidated document, which is accessible to all and which I think is such a good idea to keep this conversation going. That said, until I stop talking, there's no conversation. So maybe what I should do is begin by introducing Dr. Shirish Ravan, who is the UN Office for Outer Space Affairs in Vienna. And he coordinates the activities of the UN Platform for Space-Based Information for Disaster Management and Emergency Response, what many of you probably know as UN SPIDER. He works and has worked and continues to work extensively in countries in Asia, Africa, and the Pacific in order to provide advisory services, institutional strengthening, and outreach programs for promoting disaster risk reduction and sustainable development. And I should just mention that Dr. Ravan has also authored over 50 publications, including 20 research papers in peer-reviewed technical journals. And therefore, I'm not sure why I'm the moderator and he isn't. Anyway, be that as it may, if I may, Shirish, perhaps you could kick off for 3 minutes on what you feel are the compelling subjects that you'd like to present today.
Thank you, Randolph, for setting the tone and very nice introduction that you have given about me. Uh, Particularly, I'm really delighted that Humanitarian Response Forum is taking this topic related to the benefits of outer space and usage of space technology in humanitarian response. And this is really need of the time, because when I travel from countries to countries, specifically non-space faring countries in Asia, Pacific, or we deal with Africa, we find this gap that space technology community goes in one direction and the other decision makers, humanitarian institutions and government agencies, there is not very strong bridge. So what you're doing is very, very valuable today. Having said that, I have to just highlight that space is a very valuable infrastructure today. Just by having a mobile phone in hand, we are dealing with satellite remote sensing, the mapping, the communication, global navigation satellite systems, and weather reports that connects us with the weather satellites, meteorological satellites. So that much dependence we have on the space today, and it brings enormous benefits to society on day-to-day basis. Now, currently, world is basically focusing its development plans. The nations are focusing their development around three global frameworks. The first one is Sustainable Development Goals. The another is Sendai Framework for Disaster Risk Reduction, which is very valuable for organizations that like your organization, and also the Climate Change Agreement. So these three are the main frameworks around which we are focusing our development. And COVID-19 situation has really given us realization that these sustainable development goal and these frameworks are more important than before. Although these frameworks came into existence in 2015, with COVID-19 situation, we know that we have much more challenges than before, than the normal years. And I can highlight some of the SDGs like no poverty, zero hunger, good health and well-being, decent work and economic growth, or rising inequalities. These are the most important challenges. They are deepening now and we should address. And this is where I would like to bring in picture the Committee for Peaceful Uses of Outer Space, where UN OSA is the secretary of this committee, where all the spacefaring countries and space emerging countries, about 93 countries, they are member, and also there are a lot of observers, including some of the industries dealing with space technologies. They all come to Vienna in our committees, and then as a result, we have launched several programs for the societal benefits to bring benefits of space to humanity. And these initiatives are called like Space for Health, or Space for Youth, involving youth in our programs, or Space for Women, so that we can address the gender bias, and access to space for all, wherein even the spacefaring countries can access the space infrastructure that is in the space. So, and because of that, we are able to involve a lot of countries in the humanitarian sector, and advocate the countries that they should use space technology very effectively. And my last point is about, which is very relevant to humanitarian response, and you also mentioned about it, that's UN SPIDER, United Nations Platform for Space-Based Information for Disaster Management and Emergency Response. This particular platform has been successful to introduce the space technology benefits in the Sendai Framework for Disaster Risk Reduction, which is these days a guideline for all the countries to establish their disaster management focus for from 2015 to 2030. And this is basically enabling the disaster management agencies or humanitarian response agencies to use space effectively in all stages of disaster management, humanitarian response, and not only stops there, but it also helps in build back better, thereby developing the resilience of the countries to disasters. So I would like to just conclude by saying that the space is in our day-to-day life, and it brings a lot of benefit when humanitarian agencies like yours and around the world, they are looking into space as one of the significant infrastructure that is available for them. So I think that that's my point at this stage, and I'll come back later with more details on different things. Thank you, Randolph.
Thank you very, very much for your point. And I think a critical thing that I got out of this is we are talking about space as increasingly as part of our normal life. And I think that is really a tremendously, if not paradigmatic, change in perspective. So thank you very much indeed. I'd like to introduce Liz Cox, who is Head of International Relations for the UK, United Kingdom Space Agency's International Partnership Program, a program that spends about £30 million a year to use the United Kingdom's expertise in satellite technology and data services to deliver sustainable economic, societal, and environmental objectives. And if I can also say that, as I understand it, Liz, and I hope I'm not jumping in at the wrong time or saying the wrong thing, but I am very impressed that 44 countries fall within your purview, with 33 major projects, and I'm very, very impressed by that. If I can just quickly say that before Liz was with the Space Agency, she also worked with the Biotechnology and Biological Sciences Research Council and various multinational organizations, including Siemens, RANDS, and the Castrol. So with that, I am delighted you're here. And Liz, over to you.
Thank you very much, Professor Kent, and welcome to everybody joining today. As you, well, your lovely introduction to me, so thank you very much. As you said you mentioned our international partnership program, and so I'd like to talk about it, in terms of the challenge of how international space programs can bring innovation to the humanitarian sector. And so our International Partnership Programme, or IPP, is our Space for Sustainable Development initiative. And as my colleague on here, Shirish, was saying, very much aligned with United Nations SDGs. So IPP was really born out of a recognition that the UK space sector's capabilities in satellite technology and data services could deliver, as you said, economic, societal, or environmental benefits to people in developing countries, and essentially make a real positive difference to their lives. So, but not only that, really what we want to do is by demonstrating the value of space, and again, as Sharice mentioned, the fact that space is not a luxury, but it's critical national infrastructure, and which can and will make a tangible difference to the lives of people on the ground. And so it's essentially making, passing the message on that about the critical national infrastructure, that these space-enabled services would be able to become smarter. And it's about them being able then to have the knowledge and the confidence to make the case for investment in space going forward. So in terms of what we've actually done, well, the program's been going since 2016. As you said, Professor Kent, it's a 30 million a year, £30 million a year programme. And through that, we've part-funded 33 projects in 44 countries across Africa, Asia Pacific, and Latin America. And all of these are aimed at tackling their specific development needs. We're actually soon going to increase that portfolio even further, which is really quite exciting. So in terms of technology, all our IPP projects use Earth observation, satellite navigation, or telecommunication services paired with terrestrial data to create products or services hand in hand with international partners in new and unconventional ways. But it's really not the technology that is what lies at the heart of IPP, and rather it's about starting from the ground up rather than top down. So it's about building really trusted partnerships, which are forged from the very beginning, and they grow stronger throughout the project's lifetime, so that the end users are involved really right from the very beginning, and to ensure that the solutions develop to meet their specific needs. It's also about training or capacity building, which is a really crucial path to making sure that those positive and practical impacts are realised, and that's even after the grant funding stops. And with that in mind, it's about sustainability, such that we only consider a project a real success if a solution is used and taken up by the end user in the long term. Conscious of time, but to give you a really quick flavour of the type of activities we support, and I can probably talk about this a bit more later. We use, well, when I say we, our projects use satellite communications to deliver educational health services to people living in remote areas, tracking to identify fishermen's boats lost at sea, or Earth observation to monitor, say, dams and forecast catastrophic failures, or perhaps deliver information to smallholder farmers to enhance their crop yields. So I'll leave it there, and thank you very much.
And thank you very, very much, Liz. That's, I think one of the things in my own experience in humanitarian and development affairs is what you focused on in part, and that is this bottom up, this starting with people who actually are at the needed end of innovation. And I just think that is so important. And if I can also say, I think the range from tracing, if you like, to farming, etc., is really very, very important. And I certainly see the tremendous linkage between what you were talking about and certainly what Sharice was talking about. So thank you very, very much for that. And look forward to hearing more questions, which we have already coming in. So delighted that we'll be able to touch on some of those later on. I wondered if I could now introduce Professor Thais Russomano, who has just an extraordinary background, moving from what you might call medical issues and medical sciences to space sciences. She worked for 3 years as a space scientist at the Institute of Aerospace Medicine in Germany. She also founded a center called the Microgravity Center, which is a unique international center to study human space physiology and space biomedical engineering. And that is, I must admit, tremendously compelling. She's also a director of 2 space-related private companies, Innova Space Limited and the International Space Medicine Consortium. And I am also, want to just mention that she also is a member of the International Academy of Aviation and Space Medicine and the International Academy of Astronautics, for which she serves on the board of trustees. And then finally, because I think this is very, very relevant to all of us, she's now acting as a volunteer mentor for Space for Women, which is an innovation or an initiative by the United Nations Office for Outer Space Affairs, which you've heard about earlier. Thais, just delighted that you can come. And the only question which I have, but we can deal with that later, is why aren't you on the, if you like, space mission? Having said that, over to you, Thais.
That's the only question that I cannot answer. maybe in my heart I am. But well, in general terms, as it was said, I'm from the area of the medical issues of the presence of humans in space, and of course here on Earth as well. I worked as a terrestrial doctor for a long time in my life, and now I'm academically linked to space life science, space physiology, medicine, and so on. Not just with King's College, but other universities here in Europe and in Brazil. So my idea is when I was invited, and I take this opportunity to say thank you very much for reminding me, and I think that it is it's really a pleasure to be here. I was thinking of how to present to the general public, a kind of overview of how we combine space, health issues or medicine, and the humanitarian sector. So I divided it in, may say, in three main topics that I think that they basically give you this very good overview of how these three areas are connected. So of course, under my experience, and I will point out in each one of them how I somehow contribute to these areas. Someone said that space is in our life. I can say that space is my life, or has been my life for the last 30 years. So let's start with the first one, which is being discussed here, is satellites and space, and how it impact health issues here on Earth. And it was pretty much discussed. It can identify areas like observation of satellites that can identify areas of, let's say, forests or plantations or water, and so how this can be connected to disease like malaria, dengue, and so many other diseases that in fact we have in Brazil, in the Amazon area specifically. We have these satellites that are able to predict change in the weather or patterns in the weather and climate, so meteorological satellites. We have the telecommunication ones that are extremely important for medicine, because it gives the chance of telemedicine or telehealth to happen, and digital health to happen here on Earth, and it's extremely important. And of course, the GPS satellites, because nowadays even one of good example bringing the COVID-19 is the possibility of tracking contacts and so on through the by basically understand how the person was moving around and so on. The patient or the person that's contaminated. So all that is extremely important. It was discussed and it's very clear. I think that that's how people see space acting on here on Earth in terms of health issues. And I can just bring in an experience that I had back in the 80s when I was still a medical student, and I went to work with the survivors of a volcano disaster in Colombia that erupted back in 1985. And at that time, there was no this amount of data from satellites, and there was no mobile phones or nothing that laptops and so on. So we were much more restricted. And so I can see the difference, the impact between this pre-era of technology and this post-era of technologies that we are living in now. So it's something that it really comes to my mind many times. How many lives we could have saved if you had the technology that you have nowadays? But I feel that, as I said, this is very clear, how space and health interact. But there are other areas that I want to bring that are based on my professional life and my experience, which is space physiology. It's how the body responds to the environment of space, and space psychology. And for that, of course, we need, again, telehealth to occur. We cannot have doctors on board of spacecrafts and space stations all the time. And I want to point out that it is the telehealth or telemedicine did not start with space flights, manned space flights. It's a common mistake, that the general public has. What in fact occurred is that there was a boost, let's say, of for the telehealth area in terms of when the first flights, manned space flights start back in '61, because this is what the astronauts rely on when they are on board of a space in a space mission. But this is just, again, part of this. It's also very clear to the public. Physiology and the psychology are two areas that I would like to point out that evolved a lot because of space missions. So that if you are in space, there is it's a kind of lab. It's a human lab that cannot be reproduced here on Earth. I've been teaching a lot about space analogs, how you can try to mimic what happens in space here on Earth, but it's virtually impossible. And so this creates ways to understand our physiology in a very different perspective. Plus, we can develop some drugs in space that without the gravity, it becomes easier or at least more interesting to create or to study these drugs. Virus can be studied in space, and this also improves, let's say, the knowledge about the virus, the biology itself of the virus and how it reacts with drugs and so on. So there is all this lab that gives us lots of information about our body in space. And there is the mind. It is also impossible to reproduce what we can get from space, can gain from space when you are in a space mission. There is what's very well known called the overview effect that was created, is a term that was created to try to show this effect that the astronauts psychologically have when they look at Earth and see this blue planet, beautiful blue planet, that has this very tiny, layer of gases that it protects us so much from the environment of space, radiation, and meteorites, and so on. But it gave to the astronauts and to us, because now we can see the Earth from above, we can see the Earth in a cosmic perspective, which is a completely different scenario from 50, 60 years ago. And it changed, everybody that goes into space and comes back change, but we that are here on Earth, we are also impacted by that. It's a unit. We are a spaceship. You are a very pale blue dot in space. We have to be together. And this impact, I think that it is extremely important for humanitarian causes. Unfortunately, sometimes I think that's not used in that favor. And this satellite technology that I'm saying, this technological knowledge transfer from space to Earth in terms of physiology, in terms of telehealth, in terms of psychology, brings to the last area, which is an area that I've been dedicating my life a lot, which is education, space education and outreach. So I think that it is an important aspect that one of the pillars of my new company, Space, is related to education and outreach. And it's called, the idea, let's say, is to make it more democratic, more homogeneous, the distribution of knowledge. And I just want to cite two projects. In fact, one of them is called Kids to Mars, in which we are representing mankind globally by having kids asking questions about a trip to Mars using the 193 countries of the United Nations. And the other one, very briefly, is Valentina, which tries to empower ladies or girls all over the world in terms of to access or to work in STEM using space as a conduit.
Space. I think you've really, I must admit, I think this perspective on space as a human laboratory impacting upon our Earth, et cetera, in so many ways is going to generate a lot of questions, which I've already seen coming in. Now, having said that, I am delighted to introduce Ian Pearson, who has been a full-time futurologist for the last almost 3 decades. One of the things that I think is so relevant to have Ian being the final speaker in the first part of this session is we've seen so much that is tangible, that we understand, but what I think Ian is going to do is to push us beyond that, to say, we know in a sense where we are, but where might we be? And that's why I'm delighted that Ian, who was a doctor of science, specialist in math and physics, and has worked in cybernetics, sustainable transport, electronic cosmetics for numerous branches of engineering and aeronautic companies. And also, I should say, has something like 1,850 different inventions, including text messaging and the active contact lens, all are part of what he has done. And I should just add that he's also dealt with driverless transport as well as space travel. He was what was then British Telecom or BT's full-time futurologist from 1991 to 2007, and now runs something called Futurizon, a small futures institute. He has written something like 8 books. Once again, all you people are putting me to shame. Anyway, he has written 8 books and is a chartered fellow of the British Computer Society and a fellow of the World Academy of Art and Science. I am so delighted, Ian, to hear about what you see as, if you like, the future when it comes to outer space. Ian, over to you.
Thank you very much, Randolph. It's a great pleasure to be involved in this discussion. It seems to me that we're starting off from a very good point already. We already have low Earth orbit satellites out there. We're putting a whole stack more new ones up. Elon Musk's launching lots of new ones. And these will provide communications and broadband and internet to developing regions and lots of inaccessible places that haven't got any other way of getting this. And what that does from a humanitarian point of view is it gives people access to the global superhighway, the global commerce networks, and allows people to find a way of emerging from poverty. They can get access to education, and then of course they can get access to be able to sell stuff that they can make using that education. So we're starting from a very good point. It also stimulates various new technologies, such as, we have the high altitude balloons that places like companies like Google and Facebook have been playing with. And we can see a point in the not very far future where we're going to have floating platforms as well, which can float high up in the atmosphere. And they will do things like generating solar power and provide power to satellites and space stations and what have you. So there's lots of potential. We already have some of it, but it's very expensive to get things into space. So we need better solutions. And thinking about it from an engineering point of view, it seemed to me that we've got lots of nice new materials coming along, which offer the potential to get things faster into space. And one of those materials we keep hearing about all the time is graphene. So we have carbon nanotubes that have been around a long time. The new one is graphene, and there are various new ones like molybdenum and so on, which might be the future materials too. But what you can do with those is those materials are so strong that it's possible to pull things into space using pieces of string rather than to use rockets. So if you imagine a high altitude platform, and if you put a pulley on it and you wrap some string around that and tie one end to the rocket and you pull the string very quickly, it will accelerate that rocket very, very fast straight upwards. And if you have 2 pulleys, one is horizontal from the first one, that will then cause it to go in an arc, and then it will enter orbit. So depending how fast you pull it, you might get suborbital or you might get full orbital. And if you can do that, it doesn't use any fuel except electricity on the ground. So it's possible to do that without polluting the atmosphere full of water vapor and so on, which causes global warming and various other issues. So we designed a system using firstly high altitude platforms, and then realized that the materials you need for that have to be lighter weight than helium. And it's possible to do that if you use tiny little spheres of graphene with a vacuum inside of them. Graphene is so strong that those spheres wouldn't collapse. And if they're, say, 1 millimeter across, those little spheres, they'll be much lighter than helium. So they would float way up in the atmosphere, and you could use those as high altitude platforms. And that's exciting, but you don't have to have that platform. Imagine if you just got a parachute, one of the ones they're using for Mars landings, for example, 50 meters across. If you can get those parachutes high up in the atmosphere, they stay there for long enough that you can use them as a launch mechanism. So you could put a pulley on the bottom of those, and you can put string through that and pull them really, really fast. And of course, those parachutes will fall very quickly, and they'll fall several kilometers during the launch. But they will stay in the air long enough to do the launch. And it's possible to get full orbital velocities if you can get 15 G of acceleration. The materials are so strong. So we call that the Pythagoras sling. And it's a perfectly viable way of getting things into orbit once we have the ability to make string using graphene. We can't do that yet, but we will be able to do it in the not very far future. So I'm really excited with the potential of technologies like that, which will allow us to get these space stations and stuff into orbit, and we can go to Mars, we can build lunar things, we can put more space stations. There are lots and lots of things we can do once we have these very advanced materials. So that's really what excites me about the coming space race, is these materials can accelerate it all and make it all happen very much faster.
Very, very, very interesting. And it's amazing where this technology could go. And in that sense, let me just go back. We've got extraordinary amount of questions coming in. And if I may just say, we have got questions in from Brazil, if you like, several other countries in Latin America. We have 3 from the South Asia, 4 from Southeast Asia, 2 from the United States, 1 being Washington, D.C. I hope it's not who I think it might be. And then we have several more from other places in Europe. So it's quite a full range of not only areas and geographical areas, but also in terms of different types of questions. And let me just say, my panelists, I think what we have is about 25 or just under 25 minutes to clear a lot of questions. I wondered if you could focus on those as succinctly as possible so that we can get in your 3-minute summary at the end. So having said that, one of the questions that I have seen come in is that is the issue of how do, if you like, lesser developed countries, if you like, use and what access do they really have, practically speaking, to the kind of technologies, space technologies that others, more developed countries would have access to. So I just wondered if, Shirish, can I just ask you what your views on that might be? In other words, what and how accessible would these technologies be for lesser developed countries? And if I may just then go back to Liz and just say, Liz, could you give us some specific examples of how, as you said, from your bottom-up perspective, that these things have been received and accepted? Having said that, a very long question with not much time. So over to you, Shirish, and then Liz.
Thank you, Randolph. I think this is quite an important question, because one of the aim of the sustainable development goals is taking everyone along. No one should lag behind. And in this context, the lesser developing countries or developed countries, they really need access. And today, I mean, in today's situation is very, very good compared to the past. If you have good access to internet, I think there are a lot of open source data that are made available from NASA, NOAA, or even the European Space Agency. Even the country I'm sitting in, India, it has its portal called Bhuvan, and it's making all the data public for all the neighboring countries. So the trend has been making all the data publicly available, and they find value in that, rather than selling that data a decade ago, which was a practice, making it publicly available so that economic benefits of this data are enormous, rather than taking some profit from by selling that data. So this has really changed the scenario, and it doesn't matter how lesser developed is the country, you can access good amount of satellite images, Earth observation images. This is about the applications of images in humanitarian development or societal benefit. When it comes to a country taking a pride in accessing space resources, as I mentioned, that we have this program called Access to Space for All. Through that, we basically announce the call, and they can develop a CubeSat. And this satellite is launched through our program called program with the International Space Station and with JAXA. And with Kenya and Guatemala, these 2 countries have already launched the satellites. So now they can say, okay, they are also spacefaring countries. Or the countries that would like to send the experiment, microgravity experiments in this International Space Station or the upcoming Chinese space stations, we do have programs. So through the Committee for Peaceful Uses of Outer Space and all those initiatives which I mentioned in the first part and UN Spider program, I think we are taking along developing our countries or the countries that has not much access to that, and showing them possibility that it doesn't matter if you don't have your own satellite or your own space program, you can still access the resources and you can come along. Yeah, that's the short answer.
Thank you very, very much. And if I may just say, Liz, before handing over to you, can I just mention, we just got a question in about a study from the Ethiopian Space Science and Technology Institute, looked at drought-stricken areas in Ethiopia and how satellite data can be used. Now, somewhere between your work and Shirisha's work, there's a question here. One, if although as Shirish said, you don't need to have a satellite to be and benefit from it, but what are you seeing of specific issues that you would like to suggest are benefits to developing countries? And if I may link that, if you're involved in the Ethiopian Space Agency, are you, how do you sort of see what they're doing? So Liz, let me hand over to you.
Thank you. Yeah, and just to say, Shirish, I'm so glad you finished on that point about the fact that countries don't necessarily need to invest in their own satellite to benefit from space. And certainly, I think, you know, it's an area that we've seen previously in terms of, you know, countries do, they go to great efforts and they invest a huge amount of money in developing a satellite. And then it doesn't necessarily do everything that they want it to do afterwards. And so, again, it's about thinking about what you want it to do on the ground and looking at, and therefore looking at the satellite, you know, and because there is so much free data, or not necessarily free, but it's far less expensive than investing in a satellite. So in terms of some specific examples, we and least developed countries, I mean, certainly in our portfolio of 33 projects, we've got quite a number of them that are working in countries which are in terms of like the least developed on the OECD DAC list. And so, for example, we've been working with countries like Ethiopia, with Uganda, with Tanzania, Solomon Islands, Vanuatu, and this is anything through from delivering a drought and flood monitoring service or mitigation service, which is very pertinent at the moment in Africa. They've been having some terrible floods. Also providing climate data and forecasts to Pacific small island developing states, so that, I mean, they're really on the front line of climate change. And so it's going to enable them, it's basically providing them with much more well, strengthened data, with strong data, so that they're able to apply for climate finance with much greater success than they've been able to so far. We, through a project in Tanzania, it was basically about getting education out using satellite communications out to schools in remote areas. And through that, I think there were around over 500 teachers that were trained, and over 300 schools were provided with satellite internet access. And also in Senegal, there was a project which is based around property tax. So the Dakar city weren't able to have a clear view of mapping of changes to properties. And so this was all about using space technology to map and monitor changes, which therefore would generate greater income for them in terms of property taxes. So, you know, we've got lots and lots of examples of these kind of projects that are going on. Of course, there are some, there are great challenges to the lesser income developing countries in terms of being able to access these kind of services, products and services, but for their governments. And I was saying earlier about building the case for space. So at the moment, I mean, obviously with COVID, one key challenge that we face and we're very, very aware of is changes in budgetary priorities. And so with, like, for example, you know, the economic crisis, it's impacting us in the UK, clearly, but for lesser developed countries, it's terrible. It's absolutely terrible. And so there is then this challenge about trying to, again, get the message into the hearts and minds of policymakers that space is critical. It's absolutely critical, and try not to push it down the agenda. And just to finalize on that one. So one of the things that we've been working on is trying to fill that gap in terms of educating policymakers. So not only proving concepts through our projects to people on the ground, but also we're developing a course for policymakers in developing countries, so that, again, we can educate about the benefits of space, the applications of space, what it can do for them. So that kind of two-pronged approach in terms of proving the concept tangibly and then educating as well. We very much hope that is going to deliver quickly.
Thank you very much, Liz. You're going to see why there's a natural linkage just about to come up. Let me just give you, unfortunately, we have about just under 10 minutes because I really would like our speakers to then give their 3-minute summary. So with this vast range of questions we have, I just picked out 2. And hopefully, as the World Humanitarian Forum puts together this post-webinar paper or product, that some of these other questions you've asked can actually be included in that summary. That said, Thais, given what Liz just said, this is irresistible. If you could do it quickly, I know you'll do it substantively. And the question is this: how can we use education and education curriculum to instill desirable knowledge, skills, and attitudes that will create a technological graduate with an ability to respond to humanitarian crises through space technology? Did you get that, Thais?
It was a bit long question. No, but no, I think that, well, education is the pillar of everything, you know, because education is more than knowledge, is also, it brings awareness. And I think that it is mandatory for any kind of humanitarian action that we have this awareness about, you know, humanity and, you know, our position in space, in the, as I mentioned before, is this cosmic perspective. I think that it's interesting that we use space all the time. I said that all my life is a space life, but most of us don't have a space life, but we are always using space technology. And this is not clear. And I think that this question, in fact, could be on top of that. I'd like to say that the most common question that I always have is, why to invest in space if you have so many problems on Earth? And I think that that's complement this question, because in fact, people cannot see that without space and space technology, because of lack of education, lack of awareness, would be in a very terrible situation. As I mentioned in 1985, when I was working in Colombia, and I did not have all this technology available, I was suffering as a medical student trying to help, and people were getting sick and dying because they didn't have also access to technology. It still happens nowadays. No, it's not something that is confined to the past, unfortunately. But I think that this education is the main pillar. We need to, as space-related people, we need to better communicate that to the public.
Thank you very much, Thais. And I am really frustrated that this very fundamental question we unfortunately have so little time for, but I think you've begun to, if you like, get us on the right path. Now, if you want to see what frustration is all about, let me ask Ian the following, because Ian, you have about 2 or 3 minutes to answer the following question. And that is, what will be the top 5 space-based technologies that you think will be fundamental to provide unique contributions to an international humanitarian system? And can I just apologize before you start, Ian? How you're going to do this in 2 or 3 minutes, I don't know, but I'm sure you can. Over to you.
Sorry, I forgot to switch my microphone on. The key thing is getting global broadband network access. This allows to link with computing and encryption. It allows us to link space technology with microfinance, which is one of the really big technologies that allow women particularly to become involved in the global economy, and they can, you know, buy a goat or whatever it might be, and they can get on board. That's really, really key. Second one, of course, is environmental monitoring. If you can look after your farming and check what needs attention, what doesn't, where to put the fertilizers, that's a really big one. Materials, we all need new materials. So getting those materials like graphene, folded graphene and lighter than helium foams, that's a really key thing as well. There are massive uses from that. Asteroid mining is something which everybody will benefit from. We're talking 2040, 2050 before that starts, but that will be a really key one. And another one, which is absolutely essential, finally, the fifth one, is electromagnetic propulsion systems, which we can get hundreds of kilometers per second, which means you'd be able to get to places like Mars in a matter of a week or so, rather than several months. It's only technologies like that that will allow us to commercialize going backwards and forwards to Mars and getting materials there fast enough. Those are the really key technologies which we need. They're all feasible, they will come.
Thank you. I can't believe how well you did that. Thank you very much indeed. As far as the last one, I think you should share it with EasyJet, who must be looking for a new market. Having said that, I think it's really now time to perhaps, and very sadly, sum up, to use your last 3 minutes. I wondered if perhaps, if it's okay with you, if we just go down the same order that we began with, and if I may just ask our first speaker, Shanice, if you could kick us off. 3 minutes to summarize where you think we've been, where we should be heading in terms of this subject.
So thank you, Randolph. Yeah, I mean, such an interesting discussion and perspective given by everyone. And that helps me also to put my thoughts in very consolidated manner. So as a takeaway point from my end, I would say the most important thing for space emerging countries is to start with having a right space policy or space law or a strategy in a place. Because what we have seen that even we go on training so many people and building capacity, because there is no enabling policy environment in the country, that expertise disappears. So important is to have that kind of policies, and not only space policies or remote sensing policies, but also the humanitarian policies. For example, disaster management law or act or disaster management strategies. They should also make up mention of these technologies, utilization of these technologies. This is very important. Then the contribution can remain significant, you know, and the resources gets allocated. Another important thing is humanitarian crisis or disaster, they don't respect boundaries. And for that purpose, you need multilateral and bilateral cooperation to deal with such kind of response efforts. And space sector definitely needs this kind of cooperation. Even some space-faring countries, they don't have the satellite on top of their country when disaster has happened, and they need to ask someone else. So this kind of cooperation becomes very, very important for all the countries. The new trend now, and I think which is UK Space Agency is following very, very well, involving the private company participation or industry participation. And recently there was also big news last 1 week within India also that Indian Space Research Organization has also opened for private participation. UN OSA also is also promoting, and our committee for peaceful use of outer space also getting, increasing presence of private companies as an observer. This is very important, that providing enabling environment for private players, and that really will advance the space technologies. And one more last point is bridging the humanitarian sector and the space communities. Often there is a big gap, and these efforts need to be very, very consistent effort. We need to keep doing the outreach programs or advisories so that both the sectors, they connect on day-to-day basis, and then only it is possible to see that space is used effectively for the societal benefits or the humanitarian response. I think these are very important points that I would like to give away at the end of this.
I think your point about bridging the humanitarian and space sectors deserves, so to speak, a webinar all on its own. Thank you very much, Reece. I wonder, Liz, could we ask you for your 3-minute, sadly, summary?
Thank you. Yeah, so again, so just considering all of the comments that have been made as well, I think the key thing is just reiterating that we're all in this together.
Yes.
So as Shirish was saying about, especially for, say, lesser income developing countries, about starting with having a strategy in place, but it's about collaboration, and it's about learning from countries that already have are spacefaring nations. We've already made mistakes in some areas. We've learned from others. We're learning all the time. So collaborate, talk to other nations, and as I say, learn lessons, and consider becoming a member of or joining the Disasters Charter. This is a wonderful service which there are 17 members. The UK is a member of the Disasters Charter. So this is the International Charter on Space and Major Disasters. And this can certainly, be so advantageous to countries that are suffering from, say, natural disasters. It was recently activated, for example, Tropical Cyclone Harold in Vanuatu for the floods, and therefore able to provide satellite data. So again, it's all about this collaboration, talking to each other, building partnerships, learning from the solutions that can be developed and proven, but education. So as Thais said, it's all about education. It's about passing on knowledge, and become, for the countries that are already using satellite data successfully for humanitarian needs, become a champion, become a regional champion, and really shout about what your country has been able to do, your government has been able to do, and then become a champion in your region. I think it's a wonderful idea, and if we can all work together and shout about the benefits of space, then that's what we should be doing.
Liz, so many compelling points, including the Disaster Charter, et cetera. But you then concluded that, with the term become a regional, if you like, supporter. Is there a particular way that one would do this?
This is just a concept that I really like the idea of. So for our, again, just to use IPP, our program as an example, where we're already, say one of our projects has already proven itself as a concept. I really like the idea of then that, say that government, that ministry, becoming a champion for it within the region and passing on that knowledge, and again, shouting about the benefits of space.
Thank you very, very much, Liz. And I just wondered, Thais, given the wide spectrum of issues in which you're involved, what's your 3 minutes of, if you like, things that you're going to leave us with, or dare I say, suggest where we should be going? Over to you, Thais.
Okay, thank you. I think that I would like to, to use my 3 minutes to emphasize really it's not just the education, but the awareness that I think that it is lacking in many countries. I have the opportunity in my professional life to travel and be, let's say, professional inserted in over 40 countries, which gave me a lot of experience. And it's very clear that there is this club of countries in terms of space exploration that dominate everything, and very passively the other countries receive this information or this technology. But they are not, let's say, empowered to learn or to create their own programs, ideas, projects, and so on. That's in fact was one of the reasons that established Nova Space. Nova Space is the Innova means that this innovative approach, in the sense that the programs or the projects in education, in technology, or in outreach must be global, inclusive, diverse, and disruptive. So just as an example, I was very briefly mentioned in terms of Kids to Mars, because an outreach project that we are developing, let's say, giving face and voice to kids from 193 countries that are the member states of the United Nations. We are translating everything in the 6 languages, official language of the United Nations. It's a symbolic representation of the planet Earth, but that's the idea, is to create disruptive view, of space science, space exploration, because you are leaving Earth, our planet, to go to another planet. So it fits very well in this sense. We are also creating this reservoir of knowledge that can be accessed, and this is a complete open access project. I think that this is extremely important to empower the countries. I've been working with countries in Africa, like Angola, Zimbabwe, Botswana, and so on. It is a completely different experience for me, because, as I said, there is this club of countries that, in general, developed countries like Germany, the UK, or the US, and that dominate this area. And they do a good job, as Liz was saying, with some mistakes, learning, correcting, implementing, and so on. But it's time for us to have this broader view, and this unique view. We are one species, and that's what I said, psychologically or emotionally, that's one of the most important gain from going to space. We could see Earth from a distance. Very quickly to finalize, I had the opportunity to meet the second man that stepped on the moon, and I asked him the most important moment of his trip, and he said it was when I deleted Earth with my thumb. This is a completely different and disruptive emotional perspective of what we are. We cannot do that here on Earth if you try hard. So we are one species living in a very small place in the universe.
Thank you so very, very much, Thais. Now, finally, Ian, you've heard the travel, you've heard all the possibilities, potential, the optimism. Let me now ask you, how are you going to spend your 3 minutes?
Well, I think there is a huge amount of potential for mankind, but we really do need to be very careful as we go into the long future. It seems to me that we've got trade-offs everywhere. We have benign monitoring, which can help us to be alert of floods and catastrophes and all sorts of things, improve poverty and what have you. But on the other hand, exactly that same technology provides opportunities for rogue regimes and dictators to oppress people. So we need to be very careful about that. Similarly, people are talking about using space for making solar power and beaming it down to Earth using microwave beams. Well, we've all seen James Bond. We know how close it is before you get that technology being hacked into and somebody starts using it as a ray gun. Getting things to Mars in a week, you have to send things at hundreds of kilometers per hour. If you're sending things at that, or per second, if you're sending things at that sort of velocity, those sort of that kind of energy involved is approximating to nuclear weapon technology and actually goes far beyond it. So in the second half of the century, nuclear weapons could be the second most powerful weapons we have, simply because we'll be developing technologies to get to Mars quickly. So we need to look at space and think of the fantastic potential that it offers and all the wonderful things we can do with it. But at each stage, we need to be aware of the fact that not everybody on the planet is nice. Some people will try to abuse this, and we have to form the international collaborative structures to be able to deal with that. And it seems to me that the other people involved in this discussion are exactly the sort of people that can help to do that. So some other technology things like removing space debris, it's a simple technology issue. There's no downside to that, but there certainly is when you're militarizing space and creating phenomenally powerful systems. We really do need to be very, very careful about that. So there are lots of nice things coming along. We just need to be very careful how we develop those.
Ian, I am so grateful because in a sense, what you're saying is there's unbelievable opportunities out there,
Yeah.
but please, as you're pursuing them, be sensitive to the downside.
Exactly.
I have 1.5 minutes all to myself. So let me just make a few comments. And I think my comment is really just something I've picked up. And that is what you might call the whole global if you like, basis for this. We really are perhaps on the forefront of having a global phenomenon, global prospects, global possibilities that now, if we looked at it in terms of global, inclusive, positive disruptors, we really do have a way of saying that we're all in this in the most positive way together. Beware of the downsides, but let's pursue what we've heard today, this proliferation, the myriad upsides that we see. So now I have about 20 seconds left, and I'd like to, first of all, thank our just extraordinary speakers, the panelists who've just brought in so much foresight, insight, and experience. And I think we are all very, very grateful. I'm also very grateful to our audience who just piled me up with lots and lots of questions, most of which we weren't able to get to. But when we next have a 24-hour nonstop webinar, I think we probably get through most of the questions. And what I'd really like to do is to thank the World Humanitarian Forum for trying this out, for testing this, for, if you like, having the courage and the foresight to do something which is not necessarily mainline development, mainline humanitarian, but will be. And I think that possibly will be reflected in WHF's report that will come out of this in a few weeks. And I'd like to thank Joanna, who has guided us through, Mariana, and unbeknownst to you, you can't see him, but it's George who's been monitoring and ensuring that all our, if you like, work is working. So thank you very much to all of you. Goodbye now.